Okay, Sam wanted an example of a falling object plus sound problem. So here's an example. Let's say I drop something out of a building from here and it falls to the ground. It's going to fall to the ground and then the sound it's going to fall to the ground and then the sound will come back up to where I am, and the sum of the two I can use to find out how far it is to the ground. So let's say the falling part I'm going to call TF, and then the sound part I'm going to call T sub S. One for time falling, one for time for sound. Now, let's say in this case I drop the object and then 3.5 seconds later I hear the sound. So the time for it to fall plus the time for the sound to come back up has to add to 3.5. So I need to do each one of these separately because they are a separate problem. In the case of a falling object problem, a falling object, the distance is equal to 16 times the time to fall squared. In the case of sound, the distance is the speed of sound times the time that the sound takes. Now, I would give you a number to use for the speed of sound because it changes, but for our purposes, we'll consider it to be 1100 feet per second. Now, I still don't know what the time to fall is or the time for sound is, but I do know that this distance here and this distance here have to be equal. That distance there equals that distance there. I don't know what they are, but I know it's the same. So I'm going to set them equal to each other. 16 times the falling time squared has to equal 1100 times the time for the sound to come back up. Again, two unknowns. So I'll go back to this one here in order to get everything in one term. Now I have falling is what's squared, so I'm probably better off coming up with a substitution that incorporates that. So I'm going to isolate the time for sound by subtracting the falling time from each side. And then I'm going to plug that in here. 16 times the falling time squared is equal to 1100 times, my mistake, subtract the falling time, my mistake, 3.5 minus the falling time. From here on, it's just going to be a normal quadratic equation that I can solve using quadratic formula. Let me distribute the 1100 first. So 16 times the falling time squared is equal to, let's see, that's going to be 3850 minus 1100 times the falling time. Quadratic formula only works if you have 0 on one side, or you could complete the square, but I wouldn't recommend it in this case. So I'm going to subtract the 3850, and then I'm going to add 1100 times the falling time to both sides. So plus 1100 for the time to fall minus 3850 equals 0. Use quadratic formula. Remember, it's negative b plus or minus the square root of b squared minus 4ac all over 2a, which in this case is negative 1100 plus or minus the square root of 1100 squared minus 4 times 16 times negative 3850 divided by 2 times 16. Okay, don't be a hero, use a calculator. Fortunately, my calculator is right here. I'll enter everything in. Negative 1100 plus first, since it can't do plus or minus at the same time, the square root of 1100 squared plus 4 times 16 times 3850, close parentheses, divided by open parentheses 2 times 16, close, equals. So the falling time is 3.3379 seconds. I could do the negative one, but I'm pretty sure, or the minus case, but I'm pretty sure that's going to come out to a negative number. And it does. And I throw away the negative number because it's negative, and you can't have negative time, and it's not going to hit the ground before I drop the whatever it is. So there. So I have a falling time of 3.379 seconds. I can subtract that from 3.5, and that'll give me, that's the time for the sound to come up. But in neither case is this what I asked for. What the question asked for was how far is it down from where I dropped it. How far is this down? I want the distance. I don't care about the falling time. The falling time is just a tool to help me get what I need. So in this case, I can plug it into either one. 16 times the falling time squared, or I can plug it into 1100 times the sound time, whichever one's easier. And I'll do both to show you that it works. 3.3379 squared is equal to, let's see, 16 times 0.3379 squared is 178.2652 feet. Don't forget your units. Or I could say that it's 1100 times the 0.1621. 1100 times 0.1621. 178.31. Why is it slightly different? Rounding error. Do I care which way you do it? Nope. Do you have to do it both ways? Nope. Do it whichever way is best for you. In this case, I would say, well, it's not an exponential, so you don't need 4 decimal places. So if you just rounded it off to 178.3 feet, that's good enough for me. As long as you have units on there, and as long as you show your work, I think we should be good. Well, I hope this helped. Sam asked for it, but I thought you guys could all use it. So, there you go.